Hello and welcome to a quiet corner of curiosity, where the biggest questions in the universe get softly explored. I'm so glad you're here, whether you're settling in for the evening, taking a break from the day, or simply letting your mind wander into the profound mysteries that surround us all. Tonight, we're venturing into something truly extraordinary. We're going to explore the deepest mystery in all of existence, a question so fundamental that it touches the very fabric of reality itself. What came before the Big Bang? It's a question that has puzzled physicists, philosophers, and curious minds for decades, and the answers, or perhaps the lack of them, might just change how you think about everything. Now, I do hope this exploration isn't so fascinating that it keeps you awake, but if it does, at least you'll be pondering one of the most beautiful mysteries the cosmos has to offer. Before we begin this journey together, if you enjoy these gentle explorations into the profound, I'd be ever so grateful if you tapped the like button, subscribed, or simply left a comment telling me where in the world you're listening from and what draws you to these cosmic questions. Let me start with something that might surprise you. When we talk about the Big Bang, we're not actually talking about an explosion in space. We're talking about the expansion of space itself. Picture this: every point in the universe simultaneously beginning to stretch, carrying matter and energy along for the ride. It's less like a bomb going off and more like a balloon being inflated, except the balloon is all of reality. But here's where things get wonderfully strange. If we trace this expansion backward in time, following the universe as it shrinks and heats up, we eventually reach a point where our physics simply stops working. This isn't because physicists haven't been clever enough to figure it out. It's because we've reached the edge of what might be knowable, a place where time, space, and causality themselves begin to break down. Scientists call this moment the Planck epoch, named after the brilliant physicist Max Planck. It's the first tiny fraction of a second after the Big Bang began, roughly 10 to the minus 43 seconds. To put that in perspective, that's a decimal point followed by 42 zeros and then a 1. It's so unimaginably brief that light, the fastest thing in the universe, can only travel about 10 to the minus 35 meters in that time. That's smaller than a proton by a factor of trillions upon trillions. During this Planck epoch, the universe was so dense and hot that the four fundamental forces we know today, gravity, electromagnetism, and the strong and weak nuclear forces, were likely unified into a single force. Matter as we understand it couldn't exist. Space and time were probably fluctuating wildly, appearing and disappearing like ripples on a cosmic pond. It was a realm where quantum mechanics and general relativity, our two most successful theories of physics, both claimed dominion but refused to speak to each other. This is where we encounter our first profound mystery. Our equations literally break down. When physicists try to calculate what happened at the very beginning, they get infinities, mathematical impossibilities that signal the limits of our understanding. It's as if the universe is holding up a gentle hand and saying, "This far and no further." But that hasn't stopped brilliant minds from wondering what came before this moment. What set the cosmic clockwork in motion? The question seems almost paradoxical, because if time itself began with the Big Bang, then asking what came before is like asking what's north of the North Pole. The very concept of before might lose all meaning, yet the human mind is wonderfully stubborn when it comes to ultimate questions. We can't help but push against the boundaries of the knowable, and so cosmologists and theoretical physicists have proposed some truly remarkable ideas about what might have preceded our universe's birth. One of the most elegant possibilities is that there was no before in any conventional sense. Perhaps time itself emerged from something more fundamental, something that exists outside our usual understanding of temporal flow. Imagine a realm where causality operates by entirely different rules, where events don't follow each other in sequence, but exist in some timeless, eternal state. This leads us to one of the most mind-bending concepts in modern cosmology, the idea of eternal inflation. Picture this. Our Big Bang wasn't a unique event, but merely one bubble of expansion in an infinite, ever-inflating cosmic foam. In this view, new universes are constantly being born, each with its own physics, its own laws of nature, its own story to tell. We exist in just one of these bubbles, blissfully unaware of the countless others that might surround us in higher dimensions we cannot perceive. The mathematics behind eternal inflation are beautiful and terrifying in equal measure. They suggest that everything that can happen will happen an infinite number of times across infinite universes. There are versions of you listening to these words in countless other realities, each slightly different, each exploring the same questions we're pondering tonight. But even eternal inflation pushes the mystery back another step. If there's this eternal inflating substrate giving birth to universes, where did that come from? We find ourselves in what philosophers call an infinite regress, a chain of questions that seems to stretch backward without end. Some physicists have proposed even more radical ideas. Perhaps our universe emerged from nothing at all, quite literally. In quantum mechanics, we know that empty space isn't truly empty. It seethes with virtual particles that pop into existence and annihilate each other in time frames so brief they barely exist at all. Could our entire universe be the result of a similar quantum fluctuation, a moment when nothing became something through the strange laws of probability that govern the quantum realm? This idea, known as quantum cosmology, suggests that the universe could have tunneled into existence from a state of absolute nothingness. It's a concept that would have seemed like pure fantasy just a century ago, but quantum mechanics has taught us that reality is far stranger than our everyday experience suggests. Then there are the multiverse theories that propose our Big Bang was the result of a collision between higher dimensional spaces called branes. In this view, our three-dimensional universe is like a membrane floating in higher dimensional space. When two of these branes collide, the energy of the collision creates what we perceive as the Big Bang. It's a cosmic car crash that gives birth to space, time, and everything we know. The mathematics of these brain world scenarios are elegant, but almost incomprehensibly complex. They require us to imagine dimensions beyond our ability to visualize, geometries that exist in mathematical spaces our minds can barely grasp. Yet these theories make testable predictions, subtle signatures in the cosmic microwave background radiation that we might one day detect. What's remarkable about all these ideas is how they stretch our understanding of existence itself. They force us to question our most basic assumptions about reality, time, causality, and the nature of being. They suggest that the universe might be far stranger, far more magnificent than we ever dared imagine. But perhaps the most profound mystery isn't what came before the Big Bang, but why there's something rather than nothing at all. This question, posed by philosophers for millennia, takes on new urgency in light of our cosmic investigations. Even if we could trace the causal chain back through eternal inflation, through quantum fluctuations, through colliding brains, we would still face the ultimate question: why does anything exist? Some philosophers and physicists argue that existence is simply the default state, that nothingness is actually impossible or unstable. Others suggest that the question itself might be meaningless, that our evolved brains are simply not equipped to understand the deepest nature of reality. Yet here we are, conscious beings in a vast cosmos, able to contemplate our own existence and wonder about our cosmic origins. We are, in a very real sense, the universe becoming aware of itself, atoms arranged in such a way that they can ponder the mystery of their own existence. The story of what came before the Big Bang is still being written. Every day, new observations from space telescopes add pieces to the puzzle. Particle accelerators probe the fundamental forces that shaped the early universe. Theoretical physicists develop new mathematical frameworks that might one day bridge the gap between quantum mechanics and general relativity. We stand at the edge of a great mystery, looking back toward the ultimate beginning, knowing that we may never have complete answers, but finding profound beauty in the questions themselves. The mystery before the Big Bang isn't just a scientific puzzle. It's a mirror that reflects our deepest questions about existence, meaning, and our place in the cosmic story. As we continue this exploration, we'll delve deeper into these remarkable theories, examining the evidence that supports them and the profound implications they hold for our understanding of reality itself. What makes these questions so compelling is how they challenge our most fundamental intuitions about reality. We're accustomed to thinking in terms of cause and effect, of beginnings that follow from something that came before. But when we approach the origin of everything, these familiar concepts begin to dissolve, like sugar in cosmic tea. Consider for a moment the sheer audacity of what we're attempting. Here we are, beings made of star stuff, trying to understand the birth of the very stars that forged us. We're using brains that evolved to hunt, gather, and navigate social relationships to contemplate the deepest mysteries of existence. It's rather like trying to lift yourself up by pulling on your own bootstraps, except somehow, remarkably, we're actually making progress. One of the most intriguing aspects of this cosmic detective story is how it forces us to reconsider the nature of time itself. We experience time as a river flowing in one direction, carrying us from past to future. But Einstein showed us that time is more like a landscape where past, present, and future all exist simultaneously. Near massive objects, time slows down. At the event horizon of a black hole, it nearly stops altogether from the perspective of a distant observer. If time can be stretched and warped, if it can flow at different rates in different places, then perhaps the question of what came before the Big Bang is not quite what it seems. Perhaps we're asking the wrong question entirely. Instead of seeking a temporal predecessor to the universe, we might need to think in terms of logical or mathematical precedents, relationships that exist outside the flow of time as we understand it. This brings us to one of the most beautiful ideas in modern cosmology, the concept that the universe might be self-creating, not in some mystical sense, but through the deep mathematical relationships that govern reality. Imagine a cosmic equation so elegant that it requires its own existence, a mathematical structure so fundamental that it cannot not be. In this view, the universe exists because existence is the only logically consistent possibility. The physicist John Wheeler, who coined the term black hole, proposed what he called it from bit, the idea that all physical reality emerges from information. In this framework, the universe is essentially computational, a vast information processing system where matter, energy, space, and time are all expressions of underlying logical relationships. If Wheeler was right, then the question of what came before the Big Bang becomes a question about the nature of information itself. But let's step back and consider another profound mystery that emerges from our cosmic investigations. Why are the laws of physics so perfectly suited for the emergence of complexity, consciousness, and life? The fundamental constants of nature, the strength of gravity, the mass of the electron, the fine structure constant that governs electromagnetic interactions, all seem to be precisely tuned to allow for the existence of stars, planets, chemistry, and ultimately beings like us who can contemplate these questions. This observation has led some scientists to propose the anthropic principle, the idea that we observe a universe compatible with our existence because we couldn't exist in a universe with different laws. It's a bit like asking why you always find your keys in the last place you look. The answer is obvious, because you stop looking once you find them. Similarly, we find ourselves in a universe that permits our existence because we couldn't find ourselves anywhere else. But this explanation, while logically sound, leaves many physicists unsatisfied. It seems to suggest that our universe is somehow special, chosen from countless possibilities. The multiverse theories we touched on earlier offer a more palatable alternative. If there are indeed countless universes with different physical laws, then some of them will inevitably be suitable for life. We happen to find ourselves in one of the rare, life-permitting universes, not because it was designed for us, but because it's the only type of universe where beings like us could exist to ask the question. This perspective transforms the apparent fine-tuning from a cosmic coincidence into a selection effect. Just as puddles perfectly fit their holes, not because the holes were designed for them, but because puddles naturally conform to whatever container they find themselves in, we find ourselves in a life-friendly universe because that's the only kind where conscious observers could emerge. Yet even the multiverse hypothesis raises deeper questions. If there are infinite universes with every possible combination of physical laws, then there should be universes where the laws of physics are constantly changing, universes where mathematics itself works differently, universes so alien that we lack the conceptual framework to even imagine them. The very idea of infinite possibility becomes paradoxical when pushed to its logical conclusion. Some theorists have proposed that the multiverse itself might have a kind of natural selection, where universes that are good at producing new universes through processes like black hole formation become more common over cosmic time. In this view, our universe might be well suited not just for life, but for reproduction, spawning baby universes through the collapse of massive stars into black holes. The idea is both elegant and unsettling. It suggests that universes might evolve, developing traits that make them more successful at perpetuating themselves across cosmic generations. Our universe, with its particular balance of forces that allows for both stellar formation and stellar collapse, might be the descendant of countless previous universes, each slightly better than the last at the cosmic game of reproduction. But perhaps we're approaching this mystery from the wrong angle entirely. Throughout history, the most profound advances in human understanding have come not from answering old questions, but from realizing that we were asking the wrong questions to begin with. Copernicus didn't solve the problem of planetary motion by building better epicycles. He revolutionized astronomy by recognizing that the Earth wasn't the center of the universe. Similarly, Darwin didn't explain the complexity of life by proposing better mechanisms of special creation. He showed that complexity could emerge naturally through processes that required no designer, no predetermined plan, no external intervention. The question of how God created such perfect creatures was replaced by the understanding that creatures weren't created perfect at all, but became well adapted through the blind process of natural selection. Could it be that the question of what came before the Big Bang is similarly misguided? Perhaps we're clinging to outdated assumptions about causality, time, and the nature of existence itself. Maybe the deepest truth about cosmic origins is that there was no origin in any conventional sense, that existence is simply the natural state of affairs, as fundamental and unexplainable as mathematics itself. This possibility is both humbling and liberating. Humbling because it suggests that there might be aspects of reality that are forever beyond human comprehension, not because of practical limitations, but because of fundamental logical constraints. Liberating because it frees us from the need to find an ultimate explanation and final answer that explains everything else but requires no explanation itself. In quantum mechanics, we've learned to accept that certain questions simply don't have definite answers. You cannot simultaneously know both the position and momentum of a particle with perfect precision. This isn't a limitation of our measuring instruments, but a fundamental feature of reality. Perhaps the question of cosmic origins has a similar character, not because we lack the tools to investigate it, but because the question itself probes beyond the boundaries of what can be meaningfully asked. Yet even if ultimate answers remain forever elusive, the journey of asking these questions transforms us in profound ways. Each attempt to peer behind the cosmic curtain reveals new layers of mystery, new questions we never thought to ask, new ways of understanding our place in the grand scheme of things. We are, as Carl Sagan beautifully put it, a way for the cosmos to know itself. Through our investigations, our wonder, our persistent questioning, the universe becomes aware of its own existence. The mystery before the Big Bang isn't just a scientific puzzle to be solved. It's a mirror that reflects our deepest nature as conscious, curious beings. In seeking to understand the origin of everything, we're really seeking to understand ourselves, our purpose, our significance in a cosmos that seems simultaneously intimate and infinite, meaningful and mysterious. As we venture deeper into this cosmic mystery, we encounter something that might seem counterintuitive. The closer we look at the moment of creation, the more we realize that our very act of looking changes what we're trying to observe. It's as if the universe has a built-in privacy screen around its most intimate moments, one that becomes more opaque the harder we try to peer through it. This isn't just poetic metaphor. In quantum mechanics, the act of observation fundamentally alters the system being observed. When we try to measure a particle's position, we change its momentum. When we try to pin down its momentum, its position becomes uncertain. This observer effect might extend all the way back to the cosmic beginning, suggesting that the very question of what came before the Big Bang might be unanswerable, not because we lack the right tools, but because asking the question changes the nature of what we're trying to understand. Think about it this way. If consciousness and observation play fundamental roles in quantum mechanics, and if the early universe was governed entirely by quantum processes, then perhaps the act of conscious beings like us contemplating cosmic origins is itself part of the story. We might not be passive observers trying to decode an ancient mystery, but active participants in an ongoing cosmic narrative. This leads us to what might be the strangest idea yet proposed about cosmic origins. Some physicists and philosophers have suggested that the universe might be retroactively self-creating, that the emergence of conscious observers billions of years after the Big Bang somehow reaches backward through time to ensure the conditions necessary for their own existence. It's a cosmic bootstrap paradox, where effect becomes cause, where the future creates the past that creates the future. The mathematics behind this idea are dizzyingly complex, involving concepts from quantum mechanics that seem to violate our everyday understanding of how time works. But quantum mechanics has already shown us that particles can be entangled across vast distances. That information can seemingly travel faster than light, that the future can influence the past in ways we're only beginning to understand. If this sounds like science fiction, consider that many of the most successful theories in physics initially seemed impossible. Einstein's relativity suggested that time could slow down and space could bend. Quantum mechanics proposed that particles could exist in multiple states simultaneously until observed. These ideas were once considered absurd, but they've since been confirmed by countless experiments and form the foundation of our modern technological world. But let's explore another possibility, one that might be even more radical. What if the Big Bang wasn't the beginning of everything, but simply a phase transition in something much larger and more fundamental? Imagine the universe as we know it, emerging not from nothing, but from a different kind of existence entirely, one governed by principles so alien that we lack the conceptual vocabulary to describe them. This idea finds support in the behavior of matter under extreme conditions. When you heat ice, it melts into water. Heat it further, and it becomes steam. Apply even more energy, and the water molecules break apart into hydrogen and oxygen. Push harder still, and the atoms themselves disintegrate into a plasma of free electrons and nuclei. At even higher energies, new particles emerge, exotic forms of matter that don't exist under normal conditions. Perhaps what we call the Big Bang was a similar phase transition, a moment when some pre-existing substrate of reality underwent a transformation so complete that it created space, time, matter, and energy as we understand them. The substrate itself might be something unrecognizably different, operating according to principles that have no analog in our familiar world. This perspective suggests that asking what came before the Big Bang is like asking what water was doing before it became ice. The question assumes continuity where there might be fundamental discontinuity, a complete break in the nature of existence itself. The pre-Big Bang state might not be describable in terms of time, space, causality, or any other concept that makes sense to us. Yet even this pushes us toward an even deeper mystery. If there was some pre-existing substrate that gave rise to our universe, what gave rise to that substrate? We seem trapped in an infinite regress, a chain of questions that stretches backward without end. Each answer simply reveals a deeper layer of the mystery, like an onion that has no center, only endless layers of questions within questions. Some philosophers and physicists have argued that this infinite regress isn't a problem to be solved, but a fundamental feature of reality. Perhaps existence is like mathematics, a self-supporting structure that requires no external foundation. Just as mathematical truths don't need to be created or caused but simply are, perhaps the deepest level of reality is simply self-evident, requiring no explanation beyond its own internal logic. This brings us to one of the most profound questions in all of philosophy and science. Why is there something rather than nothing? It's a question that has puzzled thinkers for millennia, and our modern understanding of cosmic origins has only made it more pressing. Even if we could trace the causal chain back through quantum fluctuations, colliding dimensions, or eternal inflation, we would still face this ultimate puzzle. Some have argued that nothingness is actually impossible, that the very concept is incoherent. After all, true nothingness would have no properties, no laws, no possibilities. It couldn't even have the property of being nothing. In this view, existence isn't something that needs to be explained, but is simply the only coherent possibility. The absence of everything, including the absence of laws that might prevent something from existing, might actually guarantee that something must exist. Others have suggested that the question itself is meaningless, that our minds, evolved to navigate a world of objects and causes, simply aren't equipped to grapple with the deepest nature of reality. We might be like fish trying to understand what it means to be dry, forever limited by the conceptual waters in which we swim. But there's something beautiful about our persistent questioning, even in the face of potentially unanswerable mysteries. Each generation of humans looks up at the night sky and wonders about our cosmic origins. Each brings new tools, new perspectives, new ways of probing the deepest questions of existence. We build ever more sensitive telescopes, ever more powerful particle accelerators, ever more sophisticated mathematical frameworks. And with each advance, we discover that the universe is stranger, more wonderful, more mysterious than we previously imagined. The cosmic microwave background radiation, the afterglow of the Big Bang itself, carries subtle patterns that encode information about the first moments of existence. Dark matter and dark energy, invisible components that make up most of the universe, hint at physics beyond our current understanding. Gravitational waves, ripples in space-time itself, offer new ways to probe cosmic origins. Perhaps most remarkably, we've begun to realize that consciousness itself might play a fundamental role in the cosmic story. The fact that matter can organize itself in such a way that it becomes aware of its own existence seems almost miraculous. Through the emergence of consciousness, the universe has developed the capacity to contemplate its own origins, to ask questions about its own nature, to experience wonder at its own existence. We are, in a very literal sense, the universe coming to know itself. The atoms in our bodies were forged in the hearts of dying stars. The thoughts in our minds emerge from patterns of electrical activity that follow the same fundamental laws that govern galaxies and quasars. When we wonder about cosmic origins, we're participating in a kind of cosmic introspection, the universe examining its own beginnings through the lens of conscious awareness. This realization transforms the question of what came before the Big Bang from a purely academic puzzle into something deeply personal. We're not just trying to understand the origin of space and time, but the origin of the very capacity for understanding itself. We're seeking the source not just of matter and energy, but of meaning, consciousness, and the inexplicable ability to ask why in the face of an infinite cosmos. As we continue to probe these deepest mysteries, we're discovering that the boundaries between observer and observed, between questioner and questioned, might be more fluid than we ever imagined. The mystery before the Big Bang isn't just out there in some distant realm of theoretical physics. It's here now, in the very fact of our existence and our capacity to wonder about that existence. The deeper we venture into this cosmic mystery, the more we encounter what physicists call the measurement problem, but on a universal scale. In quantum mechanics, particles exist in what's known as superposition, occupying multiple states simultaneously until the moment of observation collapses them into a single, definite state. Could it be that the pre-Big Bang universe existed in a kind of cosmic superposition containing all possible realities until some form of cosmic observation brought our particular universe into being? This isn't as far-fetched as it might sound. The mathematics of quantum mechanics suggest that before measurement, a particle doesn't simply have unknown properties. It literally exists in all possible states at once. Applied to cosmology, this could mean that before the Big Bang, all possible universes existed simultaneously in a vast quantum superposition. The emergence of our universe might have been the result of this cosmic wave function collapsing into a single reality. But what could have caused such a collapse? Some theories propose that consciousness itself plays a fundamental role in quantum mechanics. If this is true, then perhaps the eventual emergence of conscious observers in our universe somehow reached backward through time to select this particular reality from the infinite possibilities that existed before the Big Bang. It's a mind-bending concept that makes conscious beings like us not just observers of the cosmos, but active participants in its creation. This leads us to consider what philosophers call the hard problem of consciousness. How does subjective experience arise from objective matter? Why is there an inner world of thoughts, feelings, and experiences that accompanies the physical processes in our brains? The mystery of consciousness is intimately connected to the mystery of cosmic origins, because both probe the deepest questions about the nature of existence itself. Some theories propose that consciousness isn't something that emerges from complex arrangements of matter, but is instead a fundamental feature of reality itself. In this view, called panpsychism, even the simplest particles possess some form of rudimentary awareness. Consciousness doesn't arise from complexity, but becomes more integrated and sophisticated as matter organizes into more complex structures. If consciousness is truly fundamental, then it might have existed in some form even before the Big Bang. Perhaps the pre-Big Bang state wasn't just a realm of quantum fields and mathematical abstractions, but possessed its own form of awareness, its own capacity for experience. The Big Bang might have been not just the birth of space and time, but the moment when cosmic consciousness began to differentiate itself into the myriad forms of awareness we see today. This perspective transforms our understanding of what it means to ask questions about cosmic origins. When we wonder about the Big Bang, we're not just we're participating in a cosmic conversationeous matter. Our consciousness to investigate uncons, consciousness examining its own deepest nature through the lens of scientific inquiry. But let's consider another profound possibility. What if time itself isn't what we think it is? Our everyday experience suggests that time flows like a river, carrying us from past to future. But Einstein's theories revealed that time is more like a landscape, where past, present, and future all exist simultaneously. From this eternal perspective, the Big Bang isn't an event that happened long ago, but something that is always happening, always present in the fabric of space-time. This eternal view of time suggests that asking what came before the Big Bang might be like asking what's east of east or what's more infinite than infinity. The question assumes a temporal framework that might not apply to the deepest levels of reality. Instead of seeking a temporal predecessor to the universe, we might need to think in terms of logical or mathematical relationships that exist outside the flow of time altogether. The physicist Julian Barber has proposed that time itself is an illusion, that what we perceive as temporal flow is really just a sequence of static moments, each containing the entire configuration of the universe. In this timeless perspective, the Big Bang becomes not the first moment of time, but simply one configuration among countless others, all equally real, all existing eternally in what Barber calls the landscape of possible moments. If Barber is correct, then the mystery before the Big Bang becomes a mystery about the nature of mathematical existence itself. Why do some mathematical structures correspond to physical reality, while others remain abstract possibilities? What determines which configurations in the landscape of moments actually exist? This brings us to what might be the most fundamental question of all: the relationship between mathematics and reality. Mathematics seems to describe the physical world with unreasonable effectiveness, as physicist Eugene Wigner famously observed. The equations of physics capture the behavior of everything from subatomic particles to galactic clusters with stunning precision. But why should this be so? Some philosophers and physicists have proposed that mathematics doesn't just describe reality, but actually is reality at its deepest level. In this view, called mathematical Platonism, physical objects are really mathematical structures, and what we perceive as the material world is simply one manifestation of eternal mathematical truths. The universe exists because the mathematical structures that describe it must exist in some abstract realm of pure logic. This mathematical view of reality offers a potential answer to the question of what came before the Big Bang. Perhaps there was no temporal before, but rather a logical precedence. The universe exists because the mathematical structures that describe it are logically necessary, existing in an eternal realm of mathematical truth that transcends space and time. But this raises new mysteries. Why do some mathematical structures manifest as physical reality while others remain purely abstract? What determines which equations describe our world rather than some other possible world? We seem to have replaced the mystery of temporal origins with the equally profound mystery of mathematical existence. The cosmologist Max Tegmark has proposed what he calls the mathematical universe hypothesis, the idea that all mathematical structures actually exist as physical realities. In this view, our universe is just one mathematical structure among infinitely many, each corresponding to a different physical reality with its own laws, its own constants, its own history. We find ourselves in this particular mathematical structure not because it's special, but because it's the kind of structure capable of supporting observers like us. This multiverse of mathematical structures would be vast beyond imagination. There would be universes where the laws of physics are slightly different, universes where mathematics itself works differently, universes so alien that we lack the conceptual framework to even imagine them. Every possible mathematical structure would correspond to some physical reality, creating an infinite ensemble of universes exploring every possible way that existence could be organized. Yet even this infinite mathematical multiverse pushes the mystery back another step. Why should mathematical structures exist at all? What gives them their reality? We seem caught in an endless regression, each answer revealing deeper layers of mystery, like an onion that has no center, but only endless layers of questions within questions. Perhaps this infinite regress isn't a problem to be solved, but a fundamental feature of existence itself. Maybe reality is like a strange loop, where every level of description depends on others, but the system as a whole is self-supporting, requiring no external foundation. The universe might exist because existence is the only logically consistent possibility, not because something caused it to exist, but because non-existence is actually impossible or incoherent. This self-supporting nature of existence finds parallels in mathematics itself. Mathematical truths don't need to be created or caused. The fact that 2 plus 2 equals 4 isn't something that happened at a particular time or place. It's simply true, necessarily and eternally. Perhaps the deepest level of physical reality has the same character of necessary existence, requiring no external explanation because it is logically self-evident. But there's something both humbling and inspiring about our persistent questioning in the face of these ultimate of probing the deepest questions of existence. We build Telisk mysteries. Each generation of humans develops new tools, new perspectives, new ways-opes that can peer back to within a fraction of a second after the Big Bang. We construct particle accelerators that recreate conditions similar to those in the first moments of cosmic history. We develop mathematical frameworks that push the boundaries of what can be conceptualized or calculated. And yet, the more we learn, the more mysterious existence becomes. Each answer reveals new questions, new depths of complexity, new layers of wonder. The cosmic microwave background radiation, the afterglow of the Big Bang itself, carries subtle patterns that encode information about quantum fluctuations in the first fraction of a second. But these patterns also hint at physics beyond our current understanding, at processes and principles that operated in realms we can barely imagine. Dark matter and dark energy, invisible components that make up most of the universe, remind us how much we still don't know about the basic constituents of reality. These mysterious substances might be clues to physics that operated before the Big Bang, remnants of processes that shaped the pre-cosmic substrate from which our universe emerged. Time itself offer new ways to probe gravitational waves, ripples in space's cosmic origins. Future gravit enough to detect the occasional wave detectors might be sensitivos of whatever process gave birth to our universe, providing direct observational evidence of pre-Big Bang physics. We might actually be able to hear the universe being born, encoded in the subtle distortions of space-time that have been propagating since the first moments of existence. Perhaps most remarkably, we're beginning to understand that information itself might play a fundamental role in cosmic origins. The physicist John Wheeler proposed that all of physical reality might emerge from information, that matter, energy, space, and time are all expressions of underlying logical relationships. In this view, the universe is essentially computational, a vast information processing system where every physical process is also a calculation. If Wheeler's it from bit hypothesis is correct, then the question of what came before the Big Bang becomes a question about the nature of information itself. Perhaps the pre-Big Bang state was a pure information, unembodied logical relationships that somehow crystallized into the physical structures we observe today. The Big Bang might have been the moment when abstract information became concrete reality, when pure logic took on the forms of space, time, matter, and energy. This informational view of reality offers a new perspective on consciousness as well. If the universe is fundamentally computational, then conscious awareness might be a particular type of information processing, a way that the universe computes its own existence. When we contemplate cosmic origins, we're not just using our consciousness to investigate unconscious matter. We're participating in the universe's ongoing computation of itself, adding our own processing power to the cosmic calculation. The boundary between observer and observed, between questioner and questioned, becomes increasingly blurred as we probe deeper into these mysteries. We are made of the same atoms that were forged in the first moments after the Big Bang. The thoughts in our minds follow the same fundamental laws that govern the cosmic expansion. When we ask questions about the origin of everything, we're really asking about the origin of our own capacity to ask questions. This realization transforms the mystery before the Big Bang from an abstract scientific puzzle into something deeply personal and immediate. We're not just trying to understand the origin of space and time, but the origin of understanding itself. We're seeking the source, not just of matter and energy, but of meaning, awareness, and the inexplicable human compulsion to ask why in the face of an infinite cosmos. As we continue to push against the boundaries of the knowable, we encounter something that might be the deepest truth of all, that mystery itself is a fundamental feature of existence. No matter how much we learn, how sophisticated our theories become, how sensitive our instruments grow, there will always be deeper questions, always another layer of mystery to explore. Perhaps this is as it should be. A universe that could be completely understood might be a universe that's ultimately boring, predictable, mechanical. The fact that existence retains its capacity to surprise us, to challenge our assumptions, to reveal new depths of complexity and beauty might be one of its most precious features. The mystery before the Big Bang isn't just a scientific problem waiting to be solved. It's a reminder of the inexhaustible nature of existence itself, an invitation to wonder, to question, to remain curious about the deepest nature of reality. In our questioning, we participate in something larger than ourselves, something that connects us to the cosmic story in the most intimate possible way. Each time we look up at the night sky and wonder about our origins, we're continuing a conversation that began with the first conscious beings who ever contemplated their place in the cosmos. We're adding our voices to an ongoing dialogue between mind and universe, between questioner and mystery. Between the known in that dialogue, we find not just and the unknowable, and scientific understanding, but a deeper appreciation for the profound gift of existence itself. The deeper we venture into this mystery, the more we encounter what might be called the observer paradox of cosmic origins. Every tool we use to investigate the Big Bang, every theory we construct, every equation we solve, emerges from minds that are themselves products of the very process we're trying to understand. It's rather like trying to see your own eyes without a mirror or attempting to bite your own teeth. This creates a strange recursive quality to our investigation. The atoms in our telescopes were forged in stellar furnaces billions of years after the Big Bang. The mathematical concepts we use to model cosmic inflation evolved in brains that developed according to laws that were established in those first fractions of a second. We are, in essence, using the universe to investigate itself, employing cosmic byproducts to understand cosmic origins. But perhaps this isn't a limitation so much as a feature. Maybe the fact that the universe has evolved conscious observers capable of contemplating its own beginning is itself a crucial piece of the puzzle. The emergence of awareness, of the capacity to ask questions and seek answers, might not be an accidental side effect of cosmic evolution, but something fundamental to the nature of existence itself. This brings us to what some philosophers call the participatory universe hypothesis. Rather than being passive observers peering at an objective reality from the outside, we might be active participants in an ongoing cosmic story. Our observations, our questions, our very existence as conscious beings might somehow be woven into the fabric of reality in ways we're only beginning to glimpse. Consider how strange it is that the universe seems so perfectly calibrated for the emergence of complexity and consciousness. If gravity were slightly stronger, stars would burn out too quickly for planets to form. If the electromagnetic force were different, atoms couldn't hold together. If the expansion rate after the Big Bang had been even minutely different, matter would either have collapsed back on itself too quickly or spread out too thin for galaxies to condense. These fine-tuning observations have led some scientists to propose what's known as the strong anthropic principle. This suggests that the universe must have properties that allow observers to exist within it, not just by coincidence, but by necessity. In this view, consciousness isn't just something that happened to emerge in a universe that permits it, but something that had to emerge for the universe to be complete. If this seems circular, consider how quantum mechanics has already shown us that observation plays a fundamental role in physical reality. The famous double slit experiment demonstrates that particles behave differently when observed than when unobserved. The act of measurement doesn't just reveal pre-existing properties, but actually determines what properties come into being. Could it be that cosmic observation works similarly? Perhaps the emergence of conscious observers billions of years after the Big Bang somehow retroactively determined the initial conditions that made their existence possible. The universe might be self-selecting, choosing its own laws and constants through the eventual emergence of beings capable of observing and questioning those laws. This leads us to contemplate what might be the strangest possibility of all, the idea that the mystery before the Big Bang might not have a solution because it's still being written. If consciousness plays a fundamental role in determining physical reality, and if conscious beings are still emerging and evolving, then perhaps the deepest nature of cosmic origins is still unfolding. We might not be investigating a completed past event, but participating in an ongoing process of cosmic self-creation. Each new observation, each theoretical breakthrough, each moment of wonder and questioning might be contributing to the universe's ongoing process of determining its own history. The past might not be fixed, but fluid, continuously shaped by present observation and future possibility. This perspective transforms our role from detectives investigating an ancient crime scene to participants in an unfolding cosmic narrative. The questions we ask about the Big Bang might influence not just our understanding of what happened, but what actually did happen. Reality might be more like an improvised story than a predetermined script, with conscious observers serving as both characters and co-authors. Such ideas push us to the very edge of what can be meaningfully discussed. We find ourselves in territory where science, philosophy, and something approaching poetry begin to converge. The mathematical precision of our equations starts to feel less like cold calculation and more like a form of cosmic music, with each new discovery adding another note to an endless symphony of understanding. Yet even in this realm of ultimate uncertainty, there's something profoundly reassuring about our capacity to ask these questions at all. The fact that matter can organize itself in such a way that it becomes curious about its own origins seems almost miraculous. Through us, through our wondering and questioning, the universe has developed the ability to contemplate its own existence. We are living proof that the cosmos is not cold and mechanical, but capable of giving rise to warmth, consciousness, love, and wonder. In our persistent questioning, in our refusal to accept easy answers or to stop pushing against the boundaries of the knowable, we embody something essential about the nature of existence itself. We are curiosity incarnate, awareness made manifest, the universe's way of marveling at itself. The mystery before the Big Bang thus becomes more than just a scientific puzzle. It becomes a mirror, reflecting our deepest nature as conscious, questioning beings. In seeking to understand the ultimate origin, we're really seeking to understand ourselves, our purpose, our place in the grand cosmic story that continues to unfold around us and through us. As our tools become more sophisticated and our theories more refined, we continue to push back the veil of mystery. But each revelation seems to uncover new layers of wonder. The cosmic microwave background radiation, mapped with ever-increasing precision, reveals subtle variations that encode the quantum fluctuations present in the first fraction of a second after the Big Bang began. These tiny ripples in the fabric of space-time eventually grew into galaxies, stars, planets, and ultimately into us. Future space missions will map this ancient light with even greater detail, potentially revealing signatures of the mysterious processes that preceded the Big Bang itself. We might detect the gravitational wave echoes of cosmic inflation, the geometric imprints of extra dimensions, or the subtle patterns left by colliding brain worlds. The technology we're developing might eventually allow us to peer back to within a tiny fraction of the Planck time, approaching ever closer to the ultimate moment of origin. But as we approach these limits, we also approach the limits of what can be meaningfully observed or calculated. The Heisenberg uncertainty principle suggests that there are fundamental limits to what can be simultaneously known about any quantum system. Applied to the universe as a whole, this might mean that complete knowledge of cosmic origins is not just practically difficult, but logically impossible. Perhaps this is for the best. A universe that could be completely understood, mapped in every detail, predicted with perfect accuracy, might lose something essential: the mystery, the wonder, the sense that there's always something more to discover. These might be among the most precious features of existence. They keep us humble, curious, always reaching towards something greater than ourselves. The question of what came before the Big Bang will likely continue to evolve as our understanding deepens. New theories will emerge, new observations will challenge old assumptions, new ways of thinking about time, space, and causality will develop. Each generation will bring fresh perspectives to these ancient questions, adding their own voices to the ongoing human conversation about cosmic origins. And in that conversation, we find something remarkable. Despite our different cultures, languages, and beliefs, humans across the globe and throughout history have looked up at the night sky and asked the same fundamental questions. Who are we? Where did we come from? Why does anything exist at all? These questions unite us in our shared humanity and our common participation in the cosmic mystery. Whether the answer lies in eternal inflation, quantum fluctuations, colliding dimensions, mathematical necessity, or something we haven't yet imagined, the search itself transforms us. Each attempt to understand cosmic origins deepens our appreciation for the profound mystery of existence. We discover that we are not separate from the universe we study, but intimately connected to it, made from its substance, governed by its laws, participants in its ongoing story of self-discovery. The mystery before the Big Bang remains unsolved, perhaps ultimately unsolvable. But in our questioning and our wondering, in our persistent reach toward understanding, we find something that might be even more valuable than answers. We find meaning, purpose, connection to something infinitely larger than ourselves, yet intimately present in every moment of conscious experience. As we continue to probe these deepest mysteries, we carry with us the accumulated wisdom of generations of questioners who came before us. We stand on the shoulders of ancient philosophers who first wondered about the nature of existence, medieval scholars who preserved and expanded human knowledge, and modern scientists who developed the tools and concepts that allow us to peer back toward the very beginning of time itself. And someday, future generations will build upon our efforts, developing new ways of thinking about these eternal questions that we can barely imagine today. The conversation continues, the mystery deepens, and the wonder never ends. In that endless questioning, we find not just scientific understanding, but something approaching the sacred, a profound appreciation for the gift of existence and our remarkable capacity to contemplate it. The mystery before the Big Bang beckons us forward, inviting us to continue the ancient human quest to understand our place in the cosmos. It reminds us that we are part of something magnificent, mysterious, and ongoing, a cosmic story that includes our questioning as one of its most beautiful chapters. The more we contemplate these ultimate questions, the more we begin to realize that our investigation itself might be changing the very nature of what we're investigating. It's a peculiar feedback loop where the act of cosmic introspection influences the cosmos being introspected. We are not merely passive observers standing outside reality, peering in through telescopes and equations. We are reality examining itself from within, consciousness emerging from the very processes we seek to understand. This recursive quality becomes even more intriguing when we consider the role of information in modern physics. Everything we observe, every measurement we make, every theory we construct, ultimately comes down to information processing. The cosmic microwave background radiation is information encoded in photons that have traveled for nearly 14 billion years. The gravitational waves detected by our instruments are information carried by ripples in space-time itself. Even the quantum fields that may have given birth to our universe can be thought of as information processing systems of unimaginable complexity. If information is truly fundamental, then perhaps the question of what came before the Big Bang becomes a question about the origin of information itself. Could it be that the pre-cosmic state was not empty nothingness, but rather pure, unprocessed information waiting to be organized into the patterns we now recognize as space, time, matter, and energy? The Big Bang might have been less like an explosion and more like the universe's first computation, the moment when abstract information began processing itself into concrete reality. This computational view of cosmic origins opens up fascinating possibilities. In computer science, we know that complex behaviors can emerge from simple rules applied repeatedly. A cellular automaton following basic instructions can generate intricate patterns that seem almost alive. Conway's game of life demonstrates how complexity can bootstrap itself from simplicity, creating structures that persist, reproduce, and evolve within their digital universe. Perhaps our universe operates on similar principles, but at a scale and complexity we can barely fathom. The laws of physics might be the fundamental algorithms running on some cosmic computational substrate, generating the rich tapestry of galaxies, stars, planets, and conscious observers that we see around us. If this is the case, then the mystery before the Big Bang becomes a question about the nature of the cosmic computer itself. What would such a substrate be made of? How would it process information? What powers it, and where did it come from? These questions push us even further into the realm of the unknowable, but they also suggest tantalizing possibilities for future investigation. If the universe is computational, then perhaps we can learn to read its code, to understand the algorithms that govern reality at its deepest level. But there's something wonderfully paradoxical about conscious beings like us trying to understand the computational nature of consciousness itself. We are using our minds to investigate how minds might emerge from information processing. We are employing our awareness to understand the origins of awareness. It's rather like using a mirror to examine the nature of reflection itself. This brings us to consider what might be the most profound aspect of the cosmic mystery we're exploring. The fact that we can ask these questions at all suggests something remarkable about the nature of existence. In a universe that began as pure energy in an unimaginably small space, matter eventually organized itself into structures complex enough to contemplate their own origins. Stars formed and died, creating the heavy elements necessary for planets. On at least one of those planets, chemistry became biology, biology became neurology, and neurology became consciousness. Through this extraordinary chain of emergence, the universe developed the capacity to know itself. We are not separate from the cosmos, but expressions of its deepest nature. When we wonder about the Big Bang, we are the universe wondering about its own beginning. When we feel awe at the vastness of space and time, we are space and time feeling awe at themselves. This perspective transforms our investigation from a purely intellectual exercise into something far more intimate. We are not trying to solve an abstract puzzle, but participating in the universe's ongoing process of self-understanding. Every telescope we build, every equation we solve, every moment of wonder we experience contributes to the cosmic conversation between mind and matter, between consciousness and cosmos. Yet the deeper we probe, the more we encounter what might be called the horizon of knowability. Just as light has a finite speed, limiting how far into space we can see, there may be fundamental limits to how far back in time we can peer, or how deeply into the nature of reality we can penetrate. These limits might not be merely practical constraints, but features of reality itself, built into the very structure of existence. Quantum mechanics already hints at such fundamental limits. The uncertainty principle tells us that some aspects of reality are inherently unknowable, not because of limitations in our measuring instruments, but because definiteness itself breaks down at the quantum level. Perhaps something similar applies to cosmic origins. Perhaps the question of what came before the Big Bang probes beyond the boundary of what can be meaningfully asked or answered. But even if ultimate answers remain forever elusive, the journey of questioning continues to transform our understanding in unexpected ways. Each attempt to peer behind the cosmic veil reveals new layers of complexity, new questions we never thought to ask, new connections between seemingly unrelated phenomena. We discover that consciousness and cosmos are more deeply intertwined than we ever imagined. The mystery deepens rather than resolves, but this deepening brings its own form of revelation. We begin to appreciate the profound gift of existence itself, the remarkable fact that anything exists at all, let alone conscious beings capable of contemplating their own existence. The universe could have remained a simple, uniform expansion of particles and radiation. Instead, it chose complexity, chose consciousness, chose the capacity for wonder. In our questioning, we honor this choice. We celebrate the universe's decision to know itself through us. Every moment of curiosity, every leap of imagination, every persistent push against the boundaries of understanding contributes to something larger than ourselves. We are participants in an ongoing cosmic awakening, consciousness slowly emerging from the depths of space and time. The mystery before the Big Bang may never be fully solved, but perhaps that's not the point. Perhaps the real revelation lies not in finding ultimate answers, but in recognizing our profound connection to the cosmic story we're trying to understand. We are not outside observers looking in, but inside participants looking around, expressions of the universe's deepest nature made manifest in minds capable of wonder. As we continue to probe these ultimate questions, we carry forward the legacy of every human who has ever looked up at the night sky and wondered. We add our voices to an ancient conversation that connects us across cultures and centuries, united by our shared participation in the grand mystery of existence. The questions change, the tools become more sophisticated, but the fundamental human drive to understand our place in the cosmos remains constant. In that drive, we find something approaching the sacred, not in the sense of religious dogma, but in the profound recognition that we are part of something magnificent and mysterious, something that includes our questioning as one of its most beautiful expressions. The universe that began in unimaginable simplicity has complexified itself into beings capable of contemplating that very beginning. The mystery before the Big Bang beckons us onward, inviting us to continue the eternal human quest for understanding. It reminds us that we are part of an ongoing story, one that includes our wonder, our questions, and our persistent reach toward truth as essential chapters in the cosmic narrative that continues to unfold through us and around us. And perhaps that's the most beautiful paradox of all. Here we are, collections of atoms that were scattered across the cosmos for billions of years, now gathered into forms complex enough to ask where we came from. The calcium in our bones was forged in stellar cores. The iron in our blood was created in supernovae. The very carbon that forms the backbone of our DNA was synthesized in the heart of dying stars. We are quite literally made of the universe, and now we turn our cosmic eyes inward, seeking to understand the moment when it all began. This brings us to something that might be even stranger than the physics we've been exploring: the role of language itself in our quest for understanding. Every word we use to describe the pre-Big Bang realm, every concept we employ, was developed by minds that evolved in a universe already billions of years old. We speak of time and space, of cause and effect, of existence and nothingness, but these concepts emerged from our experience of an already formed cosmos. When we try to describe what came before the Big Bang, we're rather like fish trying to develop a vocabulary for dryness. The very structure of our language, the way our thoughts organize themselves, reflects the physical reality in which we evolved. We think in terms of sequences because that's how we experience time. We imagine causes preceding effects because that's how causality works in our everyday world. But what if the pre-cosmic realm operated according to principles so alien that our language has no words for them? This linguistic limitation isn't just a practical inconvenience. It might represent a fundamental barrier to understanding. The philosopher Ludwig Wittgenstein once observed that the limits of our language are the limits of our world. If he was right, then perhaps the question of cosmic origins pushes us against the very boundaries of what can be meaningfully expressed or understood by minds like ours. Yet somehow, mathematics seems to transcend these limitations. Mathematical relationships appear to capture aspects of reality that ordinary language cannot express. The equations of general relativity describe the curvature of space-time itself. Quantum field theory maps the behavior of particles that exist in states our everyday experience cannot encompass. Perhaps mathematics is the universe's native language, and our ordinary words are merely rough translations. And so we find ourselves at the end of this gentle journey through the deepest mystery of all, having wandered through realms of eternal inflation, quantum fluctuations, and cosmic consciousness, yet somehow arriving exactly where we began, with wonder intact and questions multiplying like stars in an infinite sky. The mystery before the Big Bang remains beautifully, stubbornly unsolved, and perhaps that's precisely as it should be, reminding us that we are part of something far grander than answers, participants in an ongoing cosmic conversation that began with the first moment of existence and continues through every curious mind that dares to ask why anything exists at all.